People think they understand gravity. It's the first thing you learn about the world. You drop something, it falls. Simple, so simple that no one stops to question it. But that's exactly what bothers me. Because the moment you ask why it falls, everything gets uncomfortable. I've spent my life studying physics, and I want to tell you something honestly. I don't think anyone truly understands gravity. Not in the way people think they do. You see, we're very good at describing things. We can tell you what happens with incredible accuracy. But explaining why it happens? That's a very different game. In school, we're taught a neat story. Mass attracts mass. The earth pulls you down. Gravity is a force. End of explanation. But that's not understanding. That's labeling. If I ask you why the earth pulls you down, you might say, because it has mass. Fine. Then I ask, why does mass attract mass? And suddenly the room gets quiet. You see the problem? At some point, explanations stop explaining and start repeating themselves. We say gravity as if the word itself answers the question. It doesn't. We have equations. Beautiful equations. They tell us exactly how fast something falls, how planets move, how the moon stays in orbit. They work astonishingly well. But equations don't tell you what gravity is. They tell you what gravity does. That difference matters, because science isn't about memorizing formulas. It's about understanding nature. And gravity refuses to explain itself. For a long time, we were satisfied with that. As long as the predictions worked, we didn't worry too much. But something always felt wrong, because if gravity is a force, what's doing the pulling? There's no rope, no invisible arm reaching out from the earth, nothing mechanical, just motion. Then things got stranger, much stranger, because we discovered that gravity isn't really a force at all. At least not the way you think. According to our best understanding, objects aren't being pulled downward. They're moving naturally, following the straightest possible paths, through a universe that isn't straight. That sentence should bother you, because if that's true, then falling isn't caused by a force. It's caused by geometry. Space bends, time bends, and you move accordingly. So when you fall, nothing is pulling you. You are simply doing what the universe allows you to do. That sounds elegant, almost peaceful. But it raises more questions than it answers. Why does mass bend space? Why should geometry decide motion? Why this universe and not some other one? At some point, we hit a wall where physics stops answering why and starts saying, this is how nature behaves. And I want to be very clear about this. That's not a failure. That's honesty. The danger is pretending we understand something just because we can calculate it. That's how curiosity dies. Gravity is the perfect example of this trap. It feels obvious because we live inside it, but familiarity is not understanding. Right now, gravity is acting on you. It's holding you in place. It's shaping the flow of time for you ever so slightly, and you don't notice. That should tell you something. The deepest mysteries often hide inside the most ordinary experiences. So when I say people don't understand gravity, I don't mean they're ignorant. I mean they're too comfortable, too satisfied with answers that don't really answer anything. And that's where this story begins. Because gravity is not finished with us, not even close. If this made you pause for a second, if it made something familiar feel strange, good, that's where real thinking starts. If gravity is so mysterious, there's an obvious question that follows. Why does it feel so reliable? Every day, without exception, it behaves exactly as expected. You wake up, your feet meet the floor. Objects don't float away. Gravity never hesitates, never fails. And yet, we still don't know what it is. That contradiction should bother you. It bothers me. One of the most dangerous things in science is something I've seen over and over again. When a theory works too well, we stop questioning it. We confuse prediction with understanding. Gravity is the best example of this illusion. Let me show you how deep that illusion goes. When you jump, you feel a force pulling you back down. It feels obvious, but according to our best understanding, That force does not exist. Nothing is pulling you. That sounds ridiculous. So let's slow down. When you're standing still on the ground, you think you're at rest. You're not. The ground is pushing you upward. Right now. Constantly. That pressure in your feet, that's not gravity. That's the earth preventing you from falling. Now compare that to free fall. When you fall freely, you feel weightless. Not because gravity disappeared, but because nothing is stopping you anymore. No push, no resistance, just motion. This reverses everything you think you know. Free fall is not being acted upon. Free fall is the absence of force. Standing still is the unnatural state. This idea unsettles people, because it means gravity isn't doing the pushing. We are, or rather, the ground is. Here's the strange part. From your perspective, standing still feels normal. From the universe's perspective, standing still feels normal. From the universe's perspective, you are accelerating. Acceleration and gravity turn out to be indistinguishable, and that fact changes everything. If you're inside a closed box, you cannot tell whether you're being pulled by gravity or pushed by acceleration. Not by any experiment, not even in principle. That's not philosophy. That's physics. This means gravity is not something absolute. It depends on perspective. And the moment physics depends on perspective, our intuition breaks. Now let's talk about time. Because gravity doesn't just move objects, it reshapes time itself. Clocks in stronger gravity tick more slowly. That's not an interpretation, it's a measurement. A clock on the surface of the Earth ticks slower than a clock in orbit, by a tiny amount, but measurable and unavoidable. This means gravity reaches into causality. It decides the order in which events unfold. It stretches time, it squeezes time. So when you ask what gravity is, you're not asking about falling. You're asking about the structure of reality. Here's something else that makes people uncomfortable. Light has no mass, and yet light bends. It curves near massive objects. It follows gravity. That alone tells you gravity is not about mass pulling mass. It's about everything responding to the shape of space-time. And now we're in dangerous territory, because once space and time become flexible, nothing feels solid anymore. Distances change, durations change, simultaneity disappears. Two observers can disagree about what happened first, and both can be right. Gravity forces you to accept this. You don't get a choice. Either you accept a flexible universe or you give up accuracy. People often ask me, so what is gravity then? And I understand why they ask. They want a picture, a mechanism, something they can imagine. But sometimes there is no picture, only rules, only relationships, only behavior. We can tell you how gravity behaves with astonishing precision. We can send spacecraft across billions of kilometers and land them exactly where we want. We can predict eclipses centuries in advance. But if you ask me what gravity is, the honest answer is still, I don't know. That answer makes people uneasy. But it shouldn't, because pretending to know is far worse. Now let's make things even stranger. Gravity is incredibly weak. So weak that a small magnet can overpower the entire Earth's gravity on a paperclip. So why does gravity dominate the universe? Why does it shape galaxies? Why does it control the motion of stars? Because gravity never cancels. Positive and negative charges can balance. Gravity only adds. Always. Every piece of mass contributes. Over time, that adds up. Weak, but relentless. And here's where gravity becomes unavoidable. Every attempt to unify physics runs straight into it. Every other force fits neatly into quantum mechanics. Gravity refuses. When we try to describe gravity using the same language as particles and fields, the mathematics breaks. Literally, it produces infinities, nonsense results, answers that mean nothing. This isn't a small problem. It means our understanding of reality is incomplete, not missing details, missing foundations, and gravity is pointing directly at the gap. Consider black holes. They are gravity pushed to its extreme, so strong that space collapses. Time slows to a crawl. Light cannot escape. At the center, the equations stop working. They don't give wrong answers. They give no answers. That's not a bug. That's a warning. It's nature telling us, your description has reached its limit. So when people say gravity has been solved, I know what they mean. They mean it works. But working is not the same as understanding. Gravity works beautifully, mysteriously, indifferently. And maybe that's the lesson. Maybe gravity isn't here to make us comfortable. Maybe it's here to remind us that reality is deeper than our explanations. Right now, gravity is acting on you. It's shaping your future path through space-time. It's slowing your clock by an amount you'll never notice. And it's doing all of this without asking whether you understand it. That's humbling, and it's honest. If this part made gravity feel less obvious and more strange, good. That means you're paying attention. At some point, if you think about gravity long enough, you run into a strange realization. The problem isn't the equations. The problem isn't the experiments. The problem isn't the way your mind wants reality to behave. I've learned something over the years. Nature is under no obligation to match human intuition, and gravity makes that painfully clear. We evolved to survive, to judge distances, to recognize danger, to predict simple motion. We did not evolve to understand a universe where time stretches and space curves. So when gravity starts doing those things, our instincts rebel. That's why we reach for metaphors. We talk about rubber sheets. We talk about wells and slopes. We talk about forces pulling downward, not because they're accurate, but because they're familiar. The danger is forgetting that metaphors are not reality, they're crutches, and gravity snaps those crutches every chance it gets. Take down, for example. People think gravity pulls things down, but down relative to what? Down in New York is up in Australia. There is no universal down. Gravity doesn't point in a direction. It defines one. And that's already strange, a phenomenon that doesn't act within space but helps define space itself. That should tell you we're not dealing with an ordinary thing. Now think about how we describe motion. We say an object falls, but falling assumes a force, and yet, in free fall, nothing is acting on the object at all. This is one of the hardest ideas for people to accept. When you fall freely, you are not being pushed or pulled. You are simply moving naturally, unforced. The force you feel comes from resistance, from being stopped, from being held up. So the sensation you call gravity is actually the absence of freedom. That's deeply counterintuitive, and gravity doesn't care. This is why gravity destroys language. Every verb we use is wrong. Pull, fall, attract. They all imply action. But gravity is closer to permission than force. It allows motion. It doesn't cause it. Now let's talk about observation. Because gravity behaves differently depending on who is watching. From far away, an object falling toward a black hole slows down. It never quite crosses the edge. Time appears to freeze. From the object's own perspective, nothing unusual happens. It crosses the boundary without noticing anything special. Same event. Two descriptions, both correct. This isn't a trick. This is an illusion. This is how reality works. And once you accept that, you have to let go of a very comforting idea that there is a single, absolute story of what happens. Gravity refuses to give you that. Instead, it gives you consistency, different perspectives, same laws, no preferred observer. This principle sounds abstract, but it has consequences. It means reality is relational. Events don't just happen. They happen to someone. Gravity forces this upon us, and many people don't like it. They want certainty. They want objectivity that doesn't depend on viewpoint. But the universe doesn't negotiate. Now consider this. If gravity controls time, and time controls cause and effect, then gravity shapes what can influence what. Near massive objects, the future and past behave differently. Possibilities narrow, paths close. choices disappear. In extreme gravity, everything leads inward, no escape, no alternative routes. That's not just motion, that's destiny written into geometry. And here's where things get truly unsettling. Because gravity doesn't just act on matter, it acts on energy, on pressure, on momentum, even on empty space. Empty space isn't empty. It has structure, it has energy, and gravity responds to it, or maybe creates it. We're not sure. This is why the universe expands, why space itself stretches, why distant galaxies accelerate away from us. Something is counteracting gravity, something built into space, and once again, gravity reveals something unseen without explaining it. I find this fascinating, because gravity keeps acting like a messenger. It doesn't speak directly. It points. Look here. Something is missing. Look there. Your picture is incomplete. Dark matter, dark energy, space-time itself, all inferred, none directly observed, all revealed through gravity. It's almost as if gravity knows more about the universe than we do. Now let's talk about limits, because gravity brings you face to face with the edge of explanation. When we push our equations too far, they stop making sense. Infinities appear, quantities blow up, predictions lose meaning. This isn't mathematics failing. It's a sign that our description has gone beyond its domain. Gravity marks that boundary clearly, at singularities, at the beginning of the universe, at the center of black holes. These aren't places, they're warnings. Warnings that our concepts, space, time, causality, may not apply universally. And this is where humility matters, because the worst thing we can do is pretend these limits don't exist. I've always believed that admitting ignorance is the most powerful move in science, not weakness, strength. Gravity forces that honesty, because no matter how clever we are, it won't give us more than it wants to. You can calculate it, you can measure it, you can rely on it, but you cannot reduce it to something comfortable. And maybe you're not supposed to. Think about this. Gravity has shaped the universe for billions of years. Stars formed, galaxies collided, time flowed, long before humans appeared. Understanding gravity does not make gravity real. Gravity is real regardless of understanding. Understanding is something we want, not something the universe owes us. And that realization changes everything. It means the goal of physics is not to conquer mystery, it's to coexist with it. Gravity teaches patience, it teaches restraint, it teaches respect, it teaches respect for the limits of human thought. And strangely enough, that makes the universe feel more alive, not less, because mystery is not emptiness, it's depth. Right now, gravity is acting on you. It is shaping the path of every atom in your body. It is influencing your future in ways you will never notice. And it will continue to do so whether you understand it or not. That doesn't make gravity cruel, it makes it honest. If this part made you feel less certain but more curious, then it's doing its job. There's a point you reach after thinking about gravity long enough where the questions change. You stop asking, what is gravity? And you start asking, what does it mean to understand anything at all? Because gravity refuses to behave like the things we understand comfortably. You can't isolate it. You can't shield it. You can't turn it off. It's always there. Not as an object, not as a substance, but as a condition of reality itself. This makes gravity fundamentally different from everything else in physics. Electromagnetism has charges. The nuclear forces have particles. You can point to mechanisms. But gravity, it's everywhere and nowhere at once. We never observe gravity directly. That's something people don't realize. We observe motion. We observe timing. We observe light bending. And from those effects, we infer gravity, always indirectly. It's like trying to understand a wind you cannot feel by watching the shadows of trees move. Accurate, reliable, but always one step removed. And here's the strange thing. Despite this indirectness, gravity is the most trustworthy thing we know. It never lies. It never deviates. Every test confirms it. To extraordinary precision, this combination is unsettling. Perfect reliability without deep understanding. In most areas of science, understanding improves accuracy. With gravity, accuracy came first. Understanding lagged behind. And in some ways, it still hasn't caught up. Take experimental confirmation. We've tested gravity in every way we know how. On Earth, in space, with atoms, with clocks. It always behaves as predicted. But prediction is not explanation. I've always warned against confusing the two. Because once you think you understand something, you stop listening, and gravity has more to say. Let's talk about observers again. Because gravity is deeply tied to observation. Two observers watching the same event can disagree about distance, about time, about simultaneity, and gravity allows this, encourages it. This doesn't mean reality is subjective. It means reality is consistent without being absolute. There is no God's eye view, no master clock, no universal reference frame. Gravity eliminates them all. And once you accept that, you have to rethink what it means for something to be real. Is an event real if only one observer experiences it? Yes. Is it real if different observers disagree about it? Also yes. Gravity doesn't resolve these questions. It makes them unavoidable. Now let's move into dangerous territory, because here's a possibility that makes many physicists uncomfortable. Gravity may not be fundamental. This is not a fringe idea. It's a serious one. Think about temperature. Temperature feels real. You feel hot or cold. But temperature is not fundamental. It's an average. An emergent property of many particles moving. Pressure is the same. So is sound. Real effects. Not fundamental. Now ask yourself, what if gravity is like that? What if gravity emerges from something deeper, something microscopic, something we haven't identified yet? In that picture, space and time themselves may not be fundamental either. They may emerge like ripples on water, real, measurable, but not basic. Gravity would then be a consequence, not a cause, a symptom, not an explanation. This idea explains why gravity behaves so differently from other forces, why it resists quantization, why it's universal, why it's geometric. If gravity is emergent, then trying to quantize it may be like trying to quantize temperature. You're asking the wrong question. That possibility changes everything. It suggests our deepest theories are descriptions of behavior, not reality's foundation. And that's hard to accept. Because we want bedrock. We want something solid, something final. But gravity keeps pulling that bedrock away. Now think about information. Because gravity seems to care about it. Black holes absorb matter, energy, information. And yet, information cannot be destroyed. That's a rule. So where does it go? Gravity forces us to confront this paradox, and in doing so, it pulls physics into contact with philosophy. What is information? Is it physical? Does space-time store it? Does gravity encode it? These are not abstract questions. They are experimental ones, and gravity is at the center of all of them. I've always believed that the best theories don't make you comfortable. They make you curious. Gravity does that relentlessly. Every time we think we've pinned it down, it slips into a deeper layer. First force, then geometry, now maybe emergence. Each layer more subtle than the last. And that's why gravity deserves respect, not fear, not worship, respect. It teaches us patience. It teaches us intellectual humility. It teaches us that reality is not obligated to explain itself in terms we like, and yet it is explainable, just not completely, not yet. Maybe not ever, but that doesn't make the effort pointless. It makes it meaningful, because the value of science is not in final answers. It's in refining questions. Gravity refines them better than anything else. Right now, gravity is holding galaxies together. It is shaping the large-scale structure of the universe. It is influencing your body down to the smallest scale. And it does all of this without asking for your understanding. That's not indifference. That's consistency. And consistency is the universe's way of inviting us to learn. If this part pushed you closer to the edge of certainty, good. That edge is where discovery begins. After all this thinking, after all the equations, after all the experiments and theories, there's a quiet moment you reach. A moment where you realize you are not standing at the end of an answer. You are standing at the edge of what it means to understand anything at all. Gravity brings you there. People often expect science to replace mystery with certainty, but that was never the point. The point was to replace bad mysteries with better ones. Gravity does that perfectly. I've spent my life working with laws of nature, and here's something I've learned the hard way. Nature does not explain itself. It behaves, and we describe that behavior as honestly as we can. Gravity is not confusing. What's confusing is our expectation that it should make sense in a way that feels comfortable. We want causes we can picture. We want stories with beginnings and ends. We want mechanisms we can point to and say, that's the reason. Gravity refuses. It doesn't give you a reason. It gives you consistency. It works. Always. Everywhere. For everything. And it never explains itself. Think about how strange that really is. You are alive, on a spinning sphere in an expanding universe, because of a phenomenon we cannot fully explain. And yet, you trust it. Completely. You don't wake up wondering whether gravity will work today. You don't check the news to see if it's still functioning. You build your entire life on top of it. That trust doesn't come from understanding. It comes from reliability. And gravity has earned that trust without ever revealing its nature. This is where humility enters the picture. Real humility. Not the kind where you pretend to know less. The kind where you admit what knowledge actually is. Knowledge is not certainty. It's the ability to make correct predictions without lying to yourself about what you don't know. Gravity teaches that lesson relentlessly. We can predict eclipses centuries in advance. We can land machines on distant worlds. We can measure time differences caused by gravity itself. But if you ask me what gravity is, not what it does, not how it behaves, but what it is, the honest answer remains, I don't know. And that answer is not disappointing. It's liberating. Because it keeps curiosity alive. The moment you think you understand something completely, you stop listening. Gravity never lets us stop listening. Every time we think we've finished the story, it opens a deeper chapter. First, it was a force. Then it was geometry. Now it may be emergence. Tomorrow it may be something we haven't even imagined yet. That's not failure. That's progress. I've always believed the universe is more interesting than any story we can tell about it. Gravity proves that. It bends space. It stretches time. It guides motion without pushing. It dominates the universe while being unimaginably weak. It reveals invisible things without showing itself. If someone had proposed gravity as a fictional idea, people would have said it was unrealistic, too strange, too abstract, too indirect. And yet, it's real. This is why gravity matters beyond physics. It teaches a deeper lesson. It teaches us that understanding does not mean control. That explanation does not mean ownership, that the universe is not built for human intuition. And that's okay, because curiosity doesn't require comfort. It requires honesty. Gravity invites us to live with unanswered questions, not in frustration, but in wonder. Right now, gravity is shaping your path through space-time. It is slowing your clock by an amount you'll never notice. It is bending light before it reaches your eyes. It is influencing events billions of years in the future. And it does all of this without asking for permission. That's not arrogance. That's nature. If there's one thing I want you to take away from this, it's not a definition. It's an attitude. When you encounter something that works perfectly, but resists explanation, don't rush to simplify it. Don't hide the mystery. Don't pretend you understand more than you do. Stand with the question. Let it bother you. Let it sharpen your thinking. Gravity has survived every attempt to reduce it to something obvious, and that's not a weakness. That's a sign it's touching something fundamental. We may one day understand gravity in a deeper way, or we may discover that understanding itself needs to be redefined. Either way, gravity will still be there, doing exactly what it has always done, holding galaxies together, shaping time, guiding motion, quietly reminding us that reality is stranger than our best explanations. And that's not something to fear, it's something to appreciate, because the universe is not a solved problem, it's an ongoing conversation. And gravity is one of the clearest voices in it, not loud, not dramatic, just constant. If this series changed the way you think about something you once thought was obvious, then it did its job. If it made you more curious than certain, even better. And if you ever find yourself saying, "Of course that's how it works," pause. That's usually where the mystery is hiding. If you felt something click while watching this, like the video. If you enjoy thinking beyond easy answers, subscribe. And if gravity still feels simple to you, leave a comment below and tell me why. Because the most ordinary things often carry the deepest questions. And gravity is one we're still learning how to ask.